Good evening to all of you. Today is our lecture based on vectors. So I'm going to deliver you the lecture regarding what are the vectors and how can we add the two vectors and how we can subtract the two vectors, and rest of the things we will see. So through the PowerPoint slides I will show you. So I will share my desktop, and then after I will see you the PowerPoint slides. So this is our Cartesian system, and over here we have a x coordinate, y coordinate, z coordinate, and we have we have one point, and we have to draw a vector, and there are three things. One is x coordinate, another one is y coordinate, and another thing is z coordinate. So these are the planes are given, and there are the vectors v1, v2, v3. These are the vectors. So v3 vectors along z-axis, and v2 along x-axis, and v1 along y-axis. Now, or either you can write over here or here, both are the same things. So this point has three verticals, either v1, v2 and v3. There are three verticals. So it is a vector from 0 to v1, v2, v3. So this vector has three coordinates, v1, v2, v3. And it is called a V. If any vector is given, then you assume that, or it is in our mind that it has three coordinates, v1, v2, v3, x, y, and z coordinates. So vectors are uniquely identified with the points in 3 dimension or 2 dimension, or in general n dimensions. It is called the Euclidean space. Euclidean space. In this course, we have discussed only 2 dimension and 3 dimension, and we are not going to discuss 4, 5, 6 dimension, because in mathematics there are n dimensions, but we only discuss 2 or 3 dimensions. So vectors are uniquely identified with the point 3 dimension or 2 dimensions. In this course, we discuss only these 2 things. So we have a vector v1, v2, v3. And this is a vector. It can be moved anywhere, either left side or right side, or in parallel, anywhere in the same plane it can be moved. So no matter where in the space you draw a vector, it always defines the point when it's translated in parallel to the origin. So in the same matter, in the same plane, it can move anywhere, but it is on the parallel to the other vector. It can move either back side or upper side. So no matter, but within the same plane. Either here it can move. It is the same vector as previous, or I can move over here. This is the same vector, or we can go over here. So no matter whether it's move either here or here. So either we can go over here. It is the same thing, no matter. So these are just the examples for you understand. So this is the vectors that we can move, v3, v4. So next thing is vectors are uniquely identified with the points in 3 dimension or 2 dimension, or in general n dimension. So the next thing is what is the projection of the vector. There the red line is given, the red vector is given. It is called the projection of the vector v1, v2, v3, and it is denoted by, let us we denote by capital letter P, X, Y, and it is V. So on to the other plane, we have the vector upper V, and its projection is given by capital letter this P, X, Y by red color. So what is the coordinate of this pxy? V1, V2, and 0. Because of here the z coordinate is 0, that's why its coordinate is V1, V2, and V3 is 0, because of it is not the upper side, it is on the same floor. So that's why we say that. So what is the length of the vector? So we know by the Pythagoras theorem. So with the Pythagoras theorem, we can find the length of this vector. Just see the red area. If in this, from this method, we can find the length of the vector. So the length of the vector is pxy whole square is equal to v1 square plus v2 square. What about the length of the vector v? And similarly, we can find the length of the vector v. Apply Pythagoras theorem again over here. We can find the length of the vector v also. So here we apply pxy is whole square is equal to plus v3 square. So that will is equal to v1 plus v2 square as we find in the previous, and v plus v3 square. This is the idea to find the vectors. Now next thing is how to find the magnitude of the vector. For example, we have vector a1, a2, a3. So the magnitude can be found by taking the square root and squaring and square root. We can find the magnitude. So let us take an example. Suppose a is equal to minus 2, 3, 6, and we have to find the magnitude of a vector a. So adding and squaring them, then we get a magnitude of a, that is minus 2 square, 3 square, 6 square, and we get a under root 49. And the under root of 49 is 7, 7 is the 49, 7 is the magnitude of the vector a. Similarly, vectors are uniquely identified with the points 3 dimension, 2 dimension, and these are given, and a very special vector pointing from the origin to the origin is called zero vector. Another vector is called a zero vector. And what are the coordinate of the zero vector? The coordinate of the vectors zero vector, obviously the coordinates are 0, 0, 0. These are the coordinates of zero vectors. So the coordinates of zero vector are 0, 0, 0. And adding vector, if we are going to add two vectors, then add their components. For example, there are three components I, j, k. So add I to I, j to j, k to k. So this is the method to we can add these three vectors. So this is a just example. Just scalar multiplication. If I am going to multiply two vectors, so multiply, if only if I am going to multiply the vector v, then we have to multiply on ith component, we have to multiply on jth component, we have to multiply on kth component. So on the three components we have to multiply. Or here I say that v1, v2, v3. If I am going to multiply 2v1, 2v, then it's all the components we have to multiply. So this is just graphically you have seen that v1, for example, we have an scalar multiplication, and if I want to find the inverse of the vector, or if I'm going to multiply the minus of this vector, then what happens? It is on the just reverse side. If it is v1, v2, v2, and I'm going to multiply -1, it will be minus v1, minus v2, minus v3. If I am going to multiply -1 to v, it is just a reverse of the original vector. So this is called a scalar multiplication. So uh, for shorthand notification, usually we write minus v, minus v2, minus v3. So for example, one can subtract the vectors. We have two vectors a minus b, and we are going to subtract these two vectors. So each element means ith. We have to subtract ith element to ith, and jth to jth, and kth to kth. So this is the criteria from which we can multiply. We can subtract the two vectors. So scalar multiplication. And similarly, if I am going to multiply 1 into vector or vector 2, for example, here I say alpha. If I am going to multiply alpha into vector, then alpha is multiplied with each component, ith component, jth component, and kth component. So here this is a vector. For example, it is by geometrically you understand it is a vector. Any vector on a blue line passing through the origin is of the form alpha into v, of course. So alpha into v, which is a vector. What should if I wanted to write an equation of the line that does not pass through the origin? So what is the equation of the line if I am going to write? So for the help, we have to draw with the help of that blue line. I have to draw the line of this green line. So draw a vector on and that cross the green line. Here this vector I draw, and again I draw another vector. Meaning is that we have to draw the triangle like this, v, b, and this is a green vector. So we draw the triangle over here, and this thing. So now any vector on a green line is of the form w is equal to b plus alpha v for a unique alpha belongs to R. It is unique once b is fixed. So any vector on this line, on a green line, is of the form w is equal to b plus alpha v. So it is vector equation of a line. So 0 is the vector. O is the 0 vector. Its component are 0, 0. A is the position of a given point on a line. B is a vector whose direction is along the line, and t is a scalar. If t is negative, it defines a point in the opposite direction along the line. So unit vectors in the direction of A. This is called the unit vector. As I teach you in the class, unit vector just defined by a cap. A cap is equal to vector A upon modulus of A. So if I am going to split this, so split this vector into the components. So ith component is a1 upon a, jth component, and kth component. So I can split this vector into I, j, kth element. So this is a unit vector. To find the unit vector, scalar multiplication. This just whatever that I. So these are some rules. These are some rules that we read. Associativity of addition. V1 vector 1 plus V2 plus V3 is equal to this. Commutative law hold of these vectors, and identity of elements hold in this, and inverse of elements. These are some laws that you know previously, and these are just comments. Now we move further. So in 2 dimension and 3 dimension, there are three respectively special vectors I, j, and k. In this course, as I told you, we have to discuss only 2 and 3 dimensions, and not more than 3, 4 dimension, 5 dimension. We discuss only 3 dimensions. So these are the standard vectors. I is equal to 1, 0, 0. It is called the standard vector, and j is equal to 0, 1, 0. It is called the standard vector, and k is 0, 0, 1. It is like a unit vector, or it is like a standard vector. We can apply anywhere in these vectors. So these are just a unit vector for the from the diagram you can understand. So it is base side we take cos theta, and perpendicular side we take sin theta, and uh, over here we are going to multiply this. So, and if it is on the reverse side, we take upper side is a sin theta and lower side is a cos theta. So rotation is a linear function, meaning that if one were first to rotate two vectors by an angle alpha, and then to add them together, or first to add the vectors together and then rotate the results by angle theta, then one would get the same results of the vectors. So either you do this, rotate first and then add later, or either you add first or rotate later. Both the things are same. So these are just given any vectors. This vector is given, and scalar product by geometrically a dot b is equal to a mod b cos theta. And from the figure you can understand, b base we can take b cos theta, and upper side is a b, and it is a theta. So it's called the component of b in the direction of a dot b upon a. Notice that this definition of a scalar product of a vectors is coordinate independent. B cos theta. What happens if we were to introduce coordinates? So this is a coordinate, and mod x is equal to x1, v is equal to cos theta, and what is the value of this? This is a perpendicular, and v cos theta is equal to v1. Wait a minute. So what happens in general? Notice that the pair of vectors is obtained via a rotation by some angle alpha of a pair of specified case discussed on the previous slide. So these are some vectors. How do we express the new coordinates in terms of the old one? Just apply the rotation function to vectors. X is equal to x1 0 and v is equal to v1 v2, and we can obtain. So these are some examples over here. We can cut them and we get them. This is an example. So scalar product geometry we understand. Now vector equation in a plane. 0 is a 0 vector, its component is 0 0, and vector product. Now the first I discussed the dot product. Now next thing is cross product, a cross b. So the formula of cross product is a mod b sin theta, or we can say mod a mod b sin theta, and n cap. N cap is a unit vector, and it is an upward direction, whatever the direction. For example, we have coordinate is given a and b, and this is a b sin theta. Now the upward sign a cross b is in upward, just above the sign, just perpendicular to that or right hand rule is the thumb of the right hand is follows over here, a cross b sine theta. So vector product, in some books, some author says cross product, or some says vector product. So direction is in the direction of n, where n is a unit normal to a and b, such that a comma b and n form a right-handed set. Anywhere where you have a thumb of right hand, it means the normal vector goes on that direction. The magnitude of the vector product gives the area of the parallelogram spanned by A and B. And if A and B have the same direction, then sine theta is equal to 0, because of we know sine 0 is equal to 0. That is why sine theta is equal to 0. And A cross B is equal to 0, the 0 vector. A cross B is equal to minus B cross A, anti-commutative flow. So vector product, this is a formula of vector product. A cross B is equal to A mod B sine theta. Theta is the angle between A and B, and theta lies between 0 and pi. And remember that what is the formula of dot product? And the formula of dot product is A dot B cos theta, and the formula of cross product is AB sine theta. So these are two formulas, cross product and dot product. So these are some standard unit vectors I, J, K. And do you know what is the cross product of I dot I and J dot J and K dot K? The cross product of I dot I is equal to 0. Why it is 0? Because of I dot I sine 0. Because of here the angle between I dot I is 0. There is 0 angle between I dot I. That is why it will be the 0, and the angle between J and J is 0. That is why sine 0 is a 0. That is why it will become 0. And similarly, the angle between K and K is 0. That is why sine 0 is a 0. That's why it will be 0. And I dot J become K, J dot K become I, and K dot I become J. For your convenience, for your understand, you have to draw a circle, and with the help of circle, you will see. I cannot draw over here a circle, but you can see on your book there is a circle. With the help of circle, you can understand I cross J is equal to K, J cross K is equal to I, K dot I is equal to J. So this is the law of the cross product. And if I am going to just reverse, J cross I is equal to minus K, and K cross J is equal to minus I, and I cross K is equal to minus J. Non-trivial fact. Try as the challenge exercise. Cross product of vector is bilinear, meaning that A C cross A plus B is equal to C cross A plus C cross B, and A plus B plus A C is equal to A cross C plus B cross C. So a non-trivial fact by that's the complete. The logical equivalence of these two facts is easy to see. V cross W is equal to minus W cross V. This is thus it is for the instance the top identity holds. These are this identity. So lines in the space, as usual, previously we have studied that the two-dimension coordinate system, these lines were determined by a point and a direction of the slope. In 3 dimension, space, a line will also be determined by point or the direction except three-dimensional space. So it is a line and direction vector. So these are just definitions of the line, and there is just examples you will see. A parametric equation is given and symmetric, and we have to find the values. And these are some examples. Relation between lines. If the red line is down in the XY plane and the blue line is above the XY plane, but the parallel to the XY plane, the two lines never intersect and are not parallel. Determine if the lines are parallel or identical. So there are two lines, these line 1 and line 2 are given, and we have to solve these two things and find the values of and express anyone with the others. So we see that t is equal to 1. Now let t is equal to 1 for the line 2 and the point 3, 2, minus 1 is produced. Since the z coordinate are not equal, the lines are not identical. So there are some examples. Planes in the space. Next thing is there is a plane and XY plane, and there is a perpendicular in the plane. So it says for any point Q, X, Y, Z in the plane, the vector P to Q and PQ is equal to X minus X naught, comma Y minus Y naught, Z minus Z naught is also the plane. So PQ is a line and is a line on the plane. So it is denoted by this. Since the vector from P to Q in the plane PQ and N are perpendicular and their dot products must be equal to 0. Why it must be equal to 0? Because cos theta is what is, we know, dot product cos theta. Cos sine 0 is a 0 and cos 90 is a 0. That is why its dot product is always 0. So because of cos 90, the value of cos 90 is 0. That's why. So this is the two vectors, and we are going to multiply. We are going to take the dot product. So this last equation is the equation of the highlighted plane. So the equation of any plane can be found from a point in the plane and a vector normal to the plane. A standard equation of a plane containing the point x naught, y naught, z naught and having normal vectors. The equation can be simplified by using the distributive property and collecting like terms. So there are some examples. So you will see these examples. So intersection of the planes, if we have two planes and they are going to intersect each of them, so any two planes that are not parallel or identical will intersect in a line, and to find the line, solve the equation simultaneously. Because of when we are going to intersect two planes, we get a line indicated by a red color dotted line. It is a line. This line we get, and we have to find the equation of this line. So similarly, let P be any point in a plane and let Q be any point not in the plane. We are interested to find the distance from the point Q to the plane that contains the point P. We can find the distance between the point Q and the plane by projecting the vector from P to Q onto the normal to the plane, then finding its magnitude or length. So this is the projection of PQ onto the normal plane. So this is the projection of PQ. So distance between a point PQ is, so these are just examples. So now our main point, we are going to our main point. These are just examples that I, so dot product, the length of how we can find the length from the dot product. So this is the norm, and we can find how we can find the norm and dot product. The length of the vector is also called the norm. So norm is denoted by double lines, and we can calculate by squaring all the vector, adding and squaring all the vectors. So properties of length is always greater than 0. We know that if norm is equal to 1, V is called a unit vector. So if norm is equal to 0, if and only if the vector is equal to 0, and if we are going to multiply the length with the constant, then we can take the modulus of C constant outside and take the norm. These are the properties of norm. And in this example, there are two examples. First example, in fifth dimension, the length of V is equal to 0, minus 2, 1, 4, minus 2 is given by. And in the second question, there is a example in the third dimension and is given by. So how we can find the norm, how we can find the length of this vector. So this is the idea, we can find the length of this vector. So norm V is equal to 0 square minus 2 square plus 1 square, 4 square minus 2 square. And adding them, we get 25. And take the square root of the 25, we get 5. Similarly, if we are going to find the norm of V is equal to 2 upon 17 minus 2 upon 17, 3 upon 17. So again, we take the norm and add all them and squaring and adding them. So we are going to squaring and adding them, we get the norm. So this is the definition of the norm. Add all the vectors I, j, k, and squaring and adding all the vectors. It is called the norm or length of the vector. So V is a unit vector. A standard unit vector is defined by, as I told you, the standard vectors are defined by 1, 0, 0, 0, 1, 0, 0, 0, 1, and so on. So for example, in 2 dimension, the standard unit vector is defined by 1, 0, 0, 1. In 3 dimension, the standard unit vector are defined by the 1, 0, 0, 0, 1, 0, 0, 0, 1. So similarly, in 4th dimension, standard vectors are defined by 1, 0, 0, 0. So similarly, 0, 0, 0, 1, 0, 0, such type of vectors we can define as standard vectors. So 2 non-zero vectors are parallel. U is equal to CV. One is C is greater than 0. U and V have the same direction. Or if C is less than 0, U and V have an opposite direction. So these are the laws of, if 2 vectors are parallel, then this must be happens. So how we can calculate a unit vector? If V is a non-zero vector Rn, then the vector U is equal to V upon norm V. U is equal to V upon norm V. Has length 1 and has the direction of V. This vector U is called a unit vector in the direction of V. So V is a non-zero, and norm v does not is equal to 0. 1 upon norm v is greater than 0. So to find the unit vector, this is the formula to find the unit vector, that we have to u is equal to v upon norm v, and it is going to prove, it is a little proof. The vector v upon norm v is called the unit vector in the direction of v. The process of finding the unit vector in the direction of v is called the normalizing of the vector v. Finding a unit vector. For example, find the unit vector in the direction of v is equal to 3, minus 1, 2, and verify that the vector has a length 1. So how we can find the unit vector of this? So first of all, we have to find the norm. Then first of all, we have to find the norm. So norm, what we do, we have to squaring all the elements and adding them, and we get under root 14. Now second thing, what I want the, just see the formula, v upon norm v. This is the formula of unit vector. So we have to divide it with v. So we divide it 3, minus 1, 2, and below side is under root 14. Then we observe that 3 minus 1 and 2, and denominator is 14. And now insert the denominator inside. Then we have to multiply ith component, jth component, and kth component. All the components we have to multiply, and we observe that this is the unit vector. And normalizing, then 14 upon 14 is equal to 1. This, so for your understanding, it will show that it is a unit vector. So any question? Okay, so let's proceed. So distance between two vectors. The distance between two vectors u and v in Rn, to subtract them, u norm of u minus v. Properties of distance. Distance always be 0, greater than 0, and distance is equal to 0. When it will happen if and only if u is equal to v, then it will be 0. Distance of uv is equal to distance of vu. So these are some properties of the distance. Find the distance between two vectors. The distance between two vectors are given 0, 2, 2, and v vector is given 2, 0, 1. So find the distance. So the distance between u and v is equal to, we have to take the norm between u and v. So norm between 0, 2, comma 2 minus 0, and comma 2 minus 1. So it will, what we have to do, we have to find the norm, we have to take the under root and square each term and then add. So 0 minus 2 is minus 2, and squaring of minus 2 is 4, and similarly 2 minus 0 is 2, and the squaring of 2 is 2 to the 4, and similarly last thing is 2 minus 1. 2 minus 1 is 1, and square is 1, and after that adding them and take the under root, we get 3. So similarly, the dot product, some examples of the dot product. The dot product of u and v, if we have u is equal to u1, u2, u3, and we have v is equal to v1, v2, v3, is a scalar quantity, and we are going to find the dot product. Then u dot v is equal to multiply each component, u1, v1, u2, v2, So there are some one question, find the dot product of u and v. It is an fourth coordinate. So what I do, I will go multiply ith element to ith element of ith element. I will take ith element of u and multiply to ith element of v. Yani 1 multiplied by 3. And second time I will put the jth element of u and multiply the jth element of v, that is 2 multiplied by minus 2. And third time I will take the kth element of iu and the kth element of v, that is minus 3 multiplied by 2. So in this manner we multiply, and so that we get minus 7. And similarly, properties of the dot product. If u and v and w are the vectors in R, n and C is a scalar, then the following properties are true. U dot v is equal to v dot u, and u dot v plus w is equal to this. These are some properties of dot product. So C dot u dot v is equal to cu dot v, and u, or you can write this, or you can write this. So all the things are correct. So there is one another question. There are 3 vectors are given, u, v and w, and the question is find the dot product u dot v. And the second question is find the u dot v and w. And third question is u dot wv. So you will tell me the answer of this question. So u dot v, first of all tell me the answer of u dot v. So u dot v is these are some answers. Anyone tell? It's too much. Yes, your course is too much. Not it's this week. It is the syllabus. It is a part of the syllabus. There is a mistake. Where is the mistake, dear Imam? So over there we can find the u dot v. So u dot v is equal to, we have to multiply 2 multiplied by 5 and minus 2 multiplied by 8, and adding them we get minus 6. And similarly, if I am going to multiply the u dot v, that is from the first part I find u dot v is equal to minus 6, and multiply with w, and multiply with w, that's w is minus 4 and 3. So insert it inside. So minus 6 into 4 is 24, and minus 6 into 3 is 18. This is the procedure. And now third part, C part, is u into 2v. So first you will multiply 2 inside the v. So when you then take the dot product. So first I multiply 2 into v, so we get 5 to the 10 and 8 to the 16, and then you take the dot product. So let us see. So u dot 2v, and what he did, 2 dot 2, he take 2 outside and multiply it. U dot 2v. It is also true whether it can. There is one another type method. He can do like this, but my method, if you multiply first 2v and then multiply u, then you will get the same answer. Minus 12 is the same answer. Just check. There is a, and the number D part, W square, norm of W. So we know the formula of norm. What is the formula? We have to adding the squaring, and so no, first of all we have to take under root and square each element and then add. So norm of W is -4 square plus 3 square under root, and then take addition. So let's see what happens. W dot W is this. Okay, it will do, he will do like this, but if you will do like that also, then you will get the same result. And third thing is norm of W, D part is little bit, we have to check it. Maybe it is not correct, because of we have norm of W, we have to take that under root and then a square. We will do like this. And next is V minus 2W. So V is given and 2W is like this, and we get this result. Using the properties of the dot product, we get find this. So these are some example. So the angle between two vectors cos theta is equal to u dot v upon norm u not norm v. The angle between the zero vector and another vector is not defined. So theta is equal to pi, and theta is equal to when pi lies between pi by 2 and pi. So finding the angle between two vectors. These are two vectors. U and V are two vectors. So when we are going to find the norm, and we take the norm of U is under root 24 and the norm of V is under root 6, and multiply them, U dot V is equal to -12 and cos theta is this. And we know the formula of dot product. U dot V is equal to norm U norm V cos theta. Or you can write cos theta is equal to U dot V upon norm U norm V. So from here we can find, so U and V are opposite directions. So last thing is two vectors U and V are orthogonal if U dot V is equal to 0. Orthogonal means 90 degree. 90 degree happens when cos theta is equal to 90 degree. Cos 90 theta is equal to 90 degree. Because of cos 90 is 0. That is why U dot V is equal to 0. So the vector 0 is said to be orthogonal to every vector. So find the orthogonal, determine all vectors in Rn that are orthogonal to U is equal to 4, 2. So these are some example. This is the triangular inequality. No, some proof is given, and no need to read the proof. And this is the Pythagoras theorem in the vector. This is the end of the slides. So, any other question? Okay, you will see these slides at home. And next, another thing I want to mention, I will submit the week 4 assignment on the Blackboard. You will see it and submit it on the Blackboard. And no need to submit no need to go through the Wiley in this week also. Just see the assignment on the Blackboard. I just submit today. Okay. Because of some students are complaining me that there is a very huge assignments in the Wiley. So right now this week also we left that assignment. Just submit my assignment. I will give you. Just do that assignment. If you have any problem in the assignment, and just come to my office. I will give you the solution of that questions. Okay. Okay, welcome. Okay, thank you, Sultan. And your exam will be midterm exam will be start around 12th March, near about 12th March. So we prepare this. Imam, wait a minute. Just tell me, Imam.
Hi, doctor. Thank you, doctor.
How are you?
I'm fine. What about you? Are you good?
Tell me.
Okay, doctor. I want to ask about the assignment 4. Now we get it assignment, but I don't find the submission location.
No, you will go through submission location is on the same place where the extra, I create a folder, extra material. Over there you will go and try to submit the assignment for submission. There I also create a folder and you will try to submit over here.
Yeah, but we didn't, well, I didn't find until now. It's not created.
It's not created. Yeah, but I create today. I will check again. If there is some problem, then I will check again. Okay.
Okay.
Oh no, it's
And also,
no. It's Mutaib says that it's available. It is there. Click again. Just try it. Some students say that you contact your friends there.
For his class.
But
I asked my classes. They tell me it's not available until now.
Oh really? Yes. Because of you are in different class. Okay.
Yeah.
Okay. Yes. Okay. I will not give the permission to your class. Okay. I will give you. Yes. I forget it.
Thank you, doctor. And also, doctor, about midterm, it's 12th March.
Yes, it's about 12th, near about 12th, either 10th or 12th or 13th, 14th. It's near about.
Okay. The midterm will be to where? To any week? 4 or 5?
Up to 6 weeks, because of according to your syllabus it will be 7th week, but we will take approximately 6th week. I will give you the up to 6th week. Okay.
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 Thank you.
Okay.
Thank you.
Take care.